Hello, this is Dr. V covering section 1.4 on the carbon cycle. The learning objective here is to explain the steps of and reservoir interactions in the carbon cycle. Carbon cycle overview. Carbon cycle is basically the movement of molecules that contain carbon, such as CO2, glucose, and methane, between the sources and the sink, such as what you see here, where it produces all of these different things here. Some steps are very quick, for example, fossil fuel combustion. Some are very slow, such as sedimentation and burial. This leads to an imbalance in which reservoirs and sinks are storing carbon. Atmosphere is a key carbon reservoir. Increasing levels of carbon in the atmosphere leads to global warming. Carbon sink reservoir stores more carbon than it releases, such as the ocean, fossil fuels, and so forth. Carbon source is a process that adds carbon to the atmosphere, such as fossil fuel combustion, being oil, coal, natural gas, animal agriculture, where a cow burps and farts and releases methane, or deforestation, where the trees are cut down, burnt, and then you don't have CO2 being removed from the atmosphere by the trees. Photosynthesis and cellular respiration. Plants, algae, and phytoplankton undergo photosynthesis. This removes CO2 from the atmosphere and converts it to glucose. CO2 and water goes in, glucose comes out, releasing O2 for us. Glucose is a biological form of carbon and stored as chemical energy in the form of sugar. This is a carbon dioxide sink. Respiration is done by both plants and animals, and it releases stored energy. This uses oxygen to break carbon down. Oxygen and glucose goes in, releases energy. Also releases CO2 up back into the atmosphere and water. The CO2 is a source, meaning it adds CO2 back into the atmosphere. Both processes are very quick. They cycle carbon between the biosphere and atmosphere in a balanced amount. There's no net carbon increase in the atmosphere. Now, ocean and atmosphere, there's a direct exchange. CO2 moves directly between the atmosphere and the ocean by dissolving into and out of the ocean water at the surface. Happens very quickly and in equal directions, balancing the levels of CO2 between atmosphere and ocean. Because of the direct exchange, increasing atmospheric CO2 also increases the ocean CO2, leading to ocean acidification. So when there's CO2 up here, it's going to become dissolved, and it's going to go into either directly into the water or be used via photosynthesis. Algae and phytoplankton take CO2 out of the ocean and atmosphere through photosynthesis. Coral reef and marine organisms with shells also take CO2 out of the atmosphere to make calcium carbonate their exoskeleton. Sedimentation is when marine organisms die. Okay, they go here and they die. Their bodies sink to the ocean floor, where they're broken down into sediments that contain carbon. Over long periods of time, burial happens, where the pressure of the water compresses down so that the carbons and sediments on the ocean floor turn into sedimentary rock, such as limestone and sandstone. That is a long-term, down here, it's a long-term carbon reservoir. Burial, extraction, and combustion. Basically, burial is a slow geological process that stores carbon in underground sinks like sedimentary rock or fossil fuels, where it goes down over here and it's stored for long periods of time. Sediments, which are bits of rock, soil, organic material, are compressed into sedimentary rock or fossil fuels by pressure from overlying rock layers or water, down in here or over here. Fossil fuels such as coal, oil, and natural gas are formed from fossilized remains of organic material. For example, dead ferns for coal or marine algae and plankton for oil. Extraction and combustion. This digging it up, mining the fossil fuels and burning them as energy source releases carbon dioxide back into the atmosphere. Burial is the formation of fossil fuels takes far longer than extraction and combustion, which means they increase concentration in the atmosphere. In other words, this right here went down 65 million years ago. It's been down there. The CO2, the carbon that went down there 65 million years ago, hasn't been up in the atmosphere for 65 million years. And so when we burn it, it's at CO2 carbon that has not been up in the atmosphere for 65 million years. So let's look at a practice FRQ. First, we see the picture, which you have seen multiple times already. Identify one process in the diagram that happens quickly and one that happens slowly. Can you explain how the rate at which fossil fuels are transferred into the atmosphere, as shown in the atmosphere, has altered the carbon cycle over the last 250 years? Thank you, and I hope that has been helpful.